All right, so here is a 610 practice, very similar to our lesson that we went over in class. All right, so just like we did before, A, B, C, D, and similar to W, X, Y, Z. So A and W, single arc, B and X, get double arcs, Y and C get triple arcs, and Z and D get the quadruple arc, which is that symbol for me. All right, so that means I'll go ahead and mark up. I'm going to do this with the parenthetical marking method. All right, so I'm going to go, this is A, correction, B, this is C, this is D, and this is A. So there we go. I have paired, what do I call these things? Corresponding counterparts there. Okay, so now I have DAB. All right, so DAB, DAB, is going to be same as XWB. All right, so that's going to be XWB. Right, so DAB is the same as XW. Oh, wait a minute. Oh. A is my vertex, W is my vertex, ZWB, ZWX. There we go. I'm using my paired coordinate there. All right, and I have Z, I have W, Z, Y is A, D, C. A, D, C. And I have X, Y, Z is B, C, D. B, C, D. And I have A, B, C is the same as W, X, Y. W, X, Y. Well, you can't see that. Let me go zoom out, I guess. Okay, so there's how we go with that. I'm pausing for a second. Okay, and I'm back. Sorry about that. All right, so just to recap, ZWX, ADC, BCD, and WXY. Okay, so over here I'm going to mark up my line segments, single, single, double, double, triple, triple, and I'm just going to keep that one unmarked there because it's pretty crowded. All right, so this is triangle little and triangle big. All right, so AB is from triangle little, DC is from triangle little, so this is angle big, angle big. All right, so from triangle big I need AB, which is going to be WX, WX, and then DC from triangle big is going to be ZY, ZY. All right, then I have WZ, so WZ is from triangle big. XZ is from triangle, XY, sorry. XY is from triangle big. All right, so I'm going to need, and then WZ. WZ is my single arc, is my single one. But I don't really need to do that because I already have these marked. So WZ is going to be AB. And then XY. XY is lined up with BC. All right, down here I have triangle, let's say BC is from triangle little, and then WX is from triangle big. So that's little over big, little over big. Okay, so BC is paired up with XY, a little over big. XY, and then WX. WX is paired up with AB. Okay, and then over here I got ZY. ZY is a big, and then AD is a little, so this is little over big again. All right, so my ZY is DC, and AD lines up with WZ. All right, so you can see how that all kind of rolls in there. All right, so next I have, all right, so I have these values. I have WZ, I'm going to mark these up, is 3. XY is 10.5. AD is 2. So I mark those up, and I'll go up here and do the math. Okay, so you can see that the only ones that I have a proportion to is AD and WZ, right? So I'm going to do my little over big equals 2 divided by 3, right? So my my shrink proportion is 2 over 3, right? I'm going to grow, or my little over big, I need to shrink this 10/5, so it's going to be 2 over 3. I need a calculator. Pause just to get a. Okay, I have a calculator, right? So I'm going to make this smaller, right? So this is going to go from 10.5 to whatever the smaller one is, right? Big to little, right? So it's going to be 2 divided by 3 times 10.5, right? It's 7. So this is going to be 7. So this is BC equals 7, or 2/3 times 10.5. Right, so 2 times 10.5 divided by 3 is whatever way you want to do that math, equals 7. Okay, so moving on to this one. Okay, here we go. We have these two triangles here. Okay, so we have 37 degrees, 90 degrees. That means that these angles are congruent here, right? Because these angles are 90 degrees here. Okay. Well, so we have that PR. Oh, it looks like everything's already labeled. Okay, what similarity could we use to say that these are congruent? All right. Well, let's go ahead and figure out everything here. Okay. So first we have. Let's see, what's my ratio? Let's do 6. Let's go a little over big. Little over big is going to be 6.8. 6.8. Well, I can definitely use my hypotenuse. 6.8 over 8.8. 6.8 divided by 8.8, and then turn that into a fraction. 17/22s. That's an awful number. Equals 17/22s. All right, and then we're going to do 11.5, 8.5 divided by 11. 8.5 divided by 11, and then same thing, equals 17/22. So these are similar, and these are similar. These are similar. Right, so you can't necessarily say that that is similar. Right, but these two are similar, and these two are similar. So I have these angles are similar. All right, so I can say without a doubt that with side angle side postulate that they are similar. All right, so I'm going to go PTR. PTR is congruent to triangle NJL. Triangle NJL. All right, just make sure your vertices are all lined up. All right, NJL and PTR. All right, go make sure you're going through. I'm going through 2 to this vertex here to 1. 2 to the vertex to 1. All right, so now I'm going to complete this table here. The imaginary angle. So if these are all similar, that means that so if this is the congruency statement, that means P and N are congruent. So P, and that means that this is a 90-degree angle, and that R and L are congruent, so this is going to be 2. This will be 2. Okay, so if this is 90 degrees and this is 37 degrees, so 90 plus 37 equals 127, right, minus 180, because the interior angles are 180, so this is going to be 53 degrees. This will be 53 degrees. Okay, so let's do this thing here. All right, so angle R here is 53. Angle L is also 53. And angle N is 90 degrees. Okay. All right, now let's see if I think I've already done this math. Angle line segment RT to LJ, RT to, this is my big over little. All right, so this is going to be, let's see, 17, it's 20 seconds. 17, oops, no, it's going to be 17, 20 seconds inverted, which is 22 seconds, 22 seventeenths. Okay, and then PT, this is big over little, JN. So PT over JN, same thing, 22 seventeenths. And then LN, okay, so this is going from big to little, so it's going to be a shrink. So those are going to be 6.6 times 17 equals, divided by 22 is equal to 5.1. So this is going to be 6.6 times 17 over 22, because this is a shrink. This is the inverse of this. So I could actually just do like, also another way to put this is going to be 6.6 times 22 seventeenths inverted. Another way to do that. So anyway, that's how you do that one. Hope that helped out. Super simple. Slow it down. Watch it again if you need help, or if I was too fast.